the Polymath Robotics World Global Headquarters, located in the Mission District of San Francisco. We're excited to present Automate It, our weekly podcast that we've now actually done for 2 weeks in a row. I, of course, am Stefan Ilia, CEO and co-founder here at Polymath. Recently made fun of quite a bit for being too excited about my intros and told that I should try to not breathe while doing these podcasts. So from here on out, I'll try to only do a single breath for the rest of the 35-minute podcast.
And to mix things up today, I'm going to critique Stefan's wardrobe.
It's a very good wardrobe.
I think he's going for a Steve Jobs look today with a featureless black turtleneck sweater.
I've also already removed the license plate from my car so I could be more like Steve Jobs. However, my parking sticker was on that license plate, so I've been informed my car was towed.
That's what you get for parking on the street.
I only park on a helipad. This, of course, is Automate It, our weekly podcast where we BS about robots. We spend the first half playing a game where we spin up a robotics company by drawing a card for a technology we have to use and a business environment we have to be in. And then for the second part of the podcast, we talk through some topic or idea in robotics. And Ilia, what are we going to talk about this week?
All right, let's pull beach. We've done that once.
What topic are we going to talk about?
Oh, what talk about?
Yeah, you just want to get right to the beach.
I want to get right to the beach.
Are you just unhappy with staring at me in this turtleneck?
I mean,
that's like a size and a half too small.
In my ideal world, I spend 90 hours a week working beside you. But if that's not available, I guess a beach will have to do.
You're making me blush.
The CEO's dream that all employees are that excited. Our topic this week is why robots are default blocked anytime you try to work on them.
Default blocked. What a weird phrase. It sounds like something Paul Graham would say. So what business case are we playing in our game? With live sound effects mixed by DJ Kai, brought to you all the way from Waterloo, Ontario, a northern state that is yet to join the union.
I feel like these episodes are just slowly more and more doxing Kai. Would you like to read out his social security number next week?
We spent the last episode talking about intern abuse devices. We actually got a comment on our Spotify for the podcast where someone said, I'm an intern at a robotics company. The last episode made me feel unsafe. So I'm glad to make people on your team unsafe if you want to send them to listen to this. Anyway, so what's the business case that we're working in?
We're going to work on a beach this week, which we have done before. I think we did a towel robot, but let's see if we get anything different. And while Stefan's picking that out, I'm just going to remind folks, we love comments, any kind of shares on Spotify, on LinkedIn, on whatever. So if you enjoy the show, it helps us a huge amount. If you want to just give a quick review, give a comment, give whatever. You know,
this is kind of a fun one that was top of my list. 3D printing on the beach.
That's actually a great topic.
Yeah.
There's a whole thing about that.
It's going to be easy and great and very valuable.
No, seriously. Okay. We have accidentally hit maybe a real business.
Okay.
So, I'm not a fan of the whole Burning Man culture thing, but I think some of the technology... Is it because
you don't like fun or is that you hate arts?
Both.
Okay.
Obviously both. But some of the technologies that people stick out there is usually pretty fun. The one that I really liked a few years ago, which you shouldn't actually do in a nature reserve like the playa, but is
the what?
Isn't it called the playa?
It's not called the playa. It's not. People aren't going out to the desert to hang out with the playas.
No.
That's not the Burning Man vibe.
All right. Comment if Stefan or Ilia is correct on this one. Anyway,
playa is what it's called.
Sure.
Many people in altered states have told me about how great the playa is.
All right. Well,
none of them have bragged about how they love their favorite playa.
No. So the thing I did see, though, was somebody put together a roving robot that used essentially a giant magnifying glass to fuse the sand.
Oh, that's cool.
Right? And so it's a roving 3D printer that just builds a structure by turning sand into molten glass, which is
building a structure or is that just like cutting away?
No, because what
that's
you do...
subtractive manufacturing.
No, because your material is the ground. Mm-hmm. You fuse it into a shape, and then you lift that shape and you fuse the layer under it. You lift it, you fuse,
okay.
you lift.
I didn't get that you were lifting it.
Yeah. And,
okay.
or you just leave it there and
I thought you were
whatever.
just like cutting stick my name in the sand in really big letters.
But it makes a fused material, right? That also connects to, there's actually projects on doing that on the moon. Mm-hmm. So basically you have a rover on the moon and you somehow compact the regolith into whatever you're trying to build.
So I actually had an opportunity to visit. So NASA has a site in Cape Canaveral that they call their Swamp Works, because the Lockheed Martin Skunk Works was in like Alabama or one of the swamp places. And since Florida used to be a bunch of swamps, the team lovingly called it the Swamp Works. And they had a massive 3D printer whose whole intent was to 3D print regolith, so that, for a moon colony, we could build blocks or houses or whatever out of 3D printed materials.
Yeah. And there's this really great NASA paper on doing that, where you use these kind of crude 3D printers to build better, more accurate mechanisms that then build the next generation, and so on, to kind of bootstrap a modern manufacturing.
There's a NASA paper, or are you talking about a blog post that I wrote but never published?
No.
That second one I know exists.
No, there's definitely a NASA paper on this, on how to bootstrap
Me and NASA, the big two.
manufacturing on the moon. But on a beach, why would you melt sand into what?
I don't think melting sand is the main option. So here's the thing. So as a kid, I often saw these really cool looking sandcastles, like, primarily in cartoons. And I liked the idea of building a cool looking sandcastle. But the sandcastle where it's just your ugly bucket turned upside down, the sandcastle where it's just like, kind of when you make the sand into mud and you drip it into a structure, that ain't me. I want to be able to compete head to head with the people who spend like 3 weeks building a sandcastle on the beach. So I want a 3D printer to build me an extravagant sandcastle on the beach.
All right. And
so that I can post it to social media and show everyone how good I am at sandcastle building. This is using a mechatronic device is the easiest way to create this Facebook post.
So what you're telling me is our business case here is purely internet points.
Yes.
All right.
Yes.
All right. So like most startup business cases. Okay. All right. Okay. So we're building a robot to compact sand into a sandcastle.
Well, I think it's more of, you could just have a large 3D printing frame, maybe like 5 feet by 5 feet, 10 feet by 10 feet ish. You have a mechanism that can shovel sand to the top of it. You keep that full, and it does the full 3D printing thing to deploy sand in the pattern.
But why gantry, right? Why not just have a rover that can, with an arm, that can deposit the sand in any way you want, and then you can have arbitrarily large sandcastles.
Well, then your height's going to be restricted by how tall that rover arm can be, and the gantry seems easier to be taller.
Yeah, it'll be in the gantry case too. I think it's more interesting.
So you need
if it's
it to be a mobile robot.
Yeah, it needs to be a mobile robot. That's more
the mobile
useful.
robot will also be harder to constantly give more sand to. It'll have to get its own sand. It'll have to dig, and then deposit.
Yes.
Whereas if I just shoveled sand into one side of my sandcastle factory,
just like a big bin.
Yeah, just like a big bin.
But then that's manual labor. Okay, you know what makes robotics better? More robots.
Yes.
So we need a little automated loader that loads the bin of the.
First, we build a robotic excavator. Check.
Yeah.
Solve digging problems.
Yeah.
Check. NBD.
Well, you take the default approach, right? It's 90% good if you just close your eyes, have no sensors, and just drive forward. Yeah. And if there's people or
they get run over,
away, they
get got.
Yeah. Shouldn't have been there.
And then we have our other robot that's a rover that deposits sand in lots of different ways. Mm-hmm. Now, most 3D printers work by having a filament of plastic that it heats up, and then the actual spigot moves around to deploy it.
Right.
If we're not, I'm assuming we're not working with liquidized sand, and we'd be using little sand pellets, or would it be easier to just make it into liquidy sand so it's more printable?
I mean, easier if you dampened it, right? Because if you just have dry sand, it will fall apart. It's not going to keep it straight.
But and you also don't have much dry sand at the beach in general.
I
guess, sorry.
I don't know what beaches you've been to. I feel like when you're on a beach, the top layer of sand is usually dry.
Beaches that are underwater.
Yeah, exactly. That's sort of the point of going to the beach. But yeah, so maybe you have to go really high tech, because you also don't want to carry on a giant jug of water. So maybe you have some sort of adhesive that you spray on, spritz on.
You have a big source of water. Why don't you just run a tube to the ocean and then drain the ocean?
So you're telling me I need a third robot to go pick up water and dump it into a canister?
Batch.
Yeah. All right. So 3 robots now. Mm-hmm. One to dig sand, one to bring water, and one to print our sandcastle.
Yep.
Are you sure you don't want to use the sun to fuse the sand and get 1,000-degree liquid glass castle.
I mean, I think you really want to burn sand.
I think it's worth less internet points, to be fair. This like lumpy, dirty colored glass won't be as cool
want it
as
to
a
look
sand
like I have a lot of artistic ability and spent a lot of time, when in reality, I just spent $500,000 on these robots, downloaded a CAD file, and hit print.
Yeah. No, that'll be doable. All right. So what sensors do we need? We've decided no obstacle avoidance. If you're in the way, it's your problem.
You get got.
Yeah. We need some sort of positioning system on the robot.
Yep.
Specifically the printer is the really important accuracy one.
Let's not talk about like 3D printer positioning, but like the actual rover itself.
Yeah.
When you just throw a RTK GPS.
Yeah. I mean, on a beach, you'd probably actually get pretty decent results.
Yeah.
You wouldn't need much.
Does saltwater interact with any of our sensing in a bad way? I mean, I know it's bad for electronics.
I mean, assuming you're not trying to print in the middle of a storm.
Yeah.
Not really.
Okay. I get less internet points.
On a sunny day, like your average beach day, you'd be fine. You wouldn't notice. Actually, the main thing you get is if you're using any kind of camera, you get sun blinded.
Yeah.
But we don't have to use cameras here because we're not going to avoid anything.
Yeah. We'll just run it all over.
Stay out of the way.
Okay. So we have 3D printer doing normal 3D printing things. Actually, are there any 3D printers that are on a mobile base? Is that a thing anyone's built?
No. Well, the way you do this is you put your media depositing head on an arm of some kind.
Yeah.
And that's it. Like,
well, yeah,
plenty of people have done
I thought your that arm was on a mobile base so they could drive around an indefinitely large thing.
Yeah. Yeah, absolutely. So it's exactly that. It's mobile based robot, which take your pick, there's thousands. And then relatively cheap arm.
Sorry, but my question, is there anyone currently doing 3D printing where your reference frame changes? So like theoretically, what's neat about using this like arm on a mobile base, you could have two printers working in tandem to do whatever.
Yeah.
That doesn't sound like software that I just get from
there are
the software
people,
store.
I'm trying to remember what it was. It was in a European country. I'm going to call Belgium, but I don't remember. There's somebody who
never
basically
trust the Belgians.
3D printed a metal walkway bridge across a canal, doing exactly that. They had two robots, one on either side of the canal, that printed their way to the middle.
Okay,
and that was like a real mobile-based collaborative.
Okay.
Welding.
That sounds like a paper.
No, like they did it in reality.
No, but that sounds like they did it for a paper.
Oh, yeah.
Are there any
like
products out there?
No. Nobody,
okay, so we have to
cannot sell. Yeah, nobody sells this.
Yeah, and we probably have to come up with a way of taking the single file of what you want to print and breaking it down into multiple different jobs to be done.
I think that's getting way too complicated. I think one robot that prints by itself, layer by layer, is already
that's
enough.
Fine. Yeah.
Like you never said you wanted internet points faster. You just want internet points. Let's say
that's why I keep all my money in Dogecoin.
So you know this thing prints a medium-sized castle in like 4 hours.
Yeah, I'd like it to be 2, but okay. So printing is a pretty known quantity. I mean, if our mobile base isn't actually mobile, our problem's not so hard, or we figure out how to solve that particular problem. So we can probably use treads on all the robots because treads work well in the sand. Yep. Is there going to be anything weird about the water carrying robot going into the water and out of the water, especially because it's going to be close to where the waves are?
There's 2 ways. One difficult one is you stick out a hose, but then you're worried about like contamination, whatever. The arguably easier way to make a submergible robot that just drives into the water with a bucket that gets filled and drives back out.
But like walking into the water on the beach is, very uneven,
just make your robot heavy.
Okay.
Right? Just make it so heavy that it doesn't notice.
1,000 pounds or 100?
Depends on the size. Right?
Yeah.
If you're talking about something, small dog sized, if it was 50, 60 pounds, it'd be too heavy to be lifted by water.
Okay.
Yeah.
But can it get stuck in the sand, especially because like as the waves pull sand away, it would get buried somewhat.
Yeah.
So you'd have an increasingly hard kinematic model.
I mean, again, I'd say if you're not trying to build this in the middle of a storm, the waves are not really something to worry about.
All right. So
Nicole's rolling her eyes and saying, wrap it up, guys.
Yeah. So we now have 3 robots. We have to figure out how to do collaborative 3D printing from mobile bases for add a 4th robot. We have a robot that has to drive underwater. And then we have a robot that just is excavating sand for us full time. What do we call this little swarm of sandcastles?
Well, the one that soaks up water from the ocean, I'm going to call SpongeBob. So I don't know. You got to name the other 2.
I think this is like a Jimi Hendrix, like castles made of sand float float into the sea eventually.
All right. So Jimi Hendrix.
The Hendrix system.
All right. The Hendrix system. Coming to you for the low price of
$50,000 to $150,000.
Yeah, 50 per robot.
Or, you can always just use OpenAI to make it pretend like you made a nice sandcastle.
Hasn't there been a proliferation of people putting up those like kid made a toy out of plastic bottles videos?
Oh, God,
images.
I love those images and people obviously falling for fakes. What are we talking about today?
Well, the first thing I want to discuss is that Stefan had a promising career as a Foley artist before
A Foley artist?
Yeah, that's people who make sound effects for movies.
Oh, yes. If only OpenAI didn't take my job and make it sound effects, I could have had a rich career like that one guy from Police Academy who everyone just knows as that guy from Police Academy.
That's right.
That could have been me.
Stefan the Foley artist.
Yeah. So talking about default blocked. So there's a great Paul Graham paper. Paul Graham, for those of you who haven't read a whole bunch of his blogs on how to start a startup, founder of YC, has a great collection of essays on how to run a startup. And there's this great one called Default Dead or Default Alive, or some combination of those two words. The basic concept being most startups are started with a magical sense of hope from the founders that at some point some magic will make them profitable. Whether that magic is a cool blog post that becomes viral, or that magic is they met this cool person and they close them for $100 million. Magic will make them profitable. And the idea of default dead versus default alive is every company is default dead if its current growth rate, if its current revenue do not support it to be profitable by the time its runway burns out. And you become default alive if either you're outright profitable or your growth, or looking forward for your growth rate over the course of your runway will lead to you being profitable before you stop growing.
Can you become profitable before there's no more money in your bank?
Yes.
Is the calculation.
It's a shorter way to say it.
Yeah.
You should try adding more paragraphs and injunctive sentences when you speak. It's very helpful.
Why do people think you're an engineer again?
So a couple months ago, we started thinking about this idea that we think of as default blocked. And this is like kind of like a play on the Paul Graham concept of default alive, that there are certain types of projects people might work on in the broad world of projects that are default blocked or default alive. If you want to do a hardware project around your house, like I've been swapping out a bunch of light switches. Before I'd ever swapped out a light switch, before I had parts to swap out a light switch, there's this big barrier to me swapping out my first light switch. And I was kind of like default blocked. So there's a hard set of things I had to learn. I had to go buy some parts. It was just naturally not going to happen. Now that I've swapped out like 3 of them, I have all the stuff. I know how to do it. It's just a matter of time before I swap out all the ugly old light switches.
Did Cassie force you to get life insurance policy before you did your first one?
No, and she has not asked about whether any of my electrical work is fire safe. So it's all gravy. Don't worry about it. For some like tech businesses, they become like default unblocked rather quickly. Like, so if, for example, you come up with an enterprising idea for a t-shirt, you go post it on something like a Teespring, you put a Google ad budget of, $500 a month into it. You reasonably can expect that $500 a month to generate $3,000 of sales. Business just kind of works. You no longer need to work on it. You can think about what the next great t-shirt idea is. You could go work on something else. You can just kind of be okay and make money. And a lot of tech companies are default unblocked. They kind of get a product that is good enough. They get a marketing machine and a sales machine that's good enough. And the founders can spend like 4 hours a day, like reading blog posts and thinking deep thoughts about how to make their companies work better. And that's, lovely. No robotics team I've ever seen has worked that way. Basically, it seems like when you work on robots, your job as a founder is to unblock the team so that they can make the next 45 minutes of progress. And then they get blocked again and you start racing to find a way to unblock them so they can make another 45 minutes of progress. And I think this is like a weird concept in robotics that most people outside of it don't really get. That the job of leadership in robotics is to basically hire a team that's good enough to do the work on their own, so leadership can make sure they keep on being able to do the work, because the sensor company decided to not actually ship stuff with the updated drivers or the updated firmware, and nothing will turn on and no one knows why for 3 days. Or the vehicle ran out of fuel, or the test site is no longer okay with you driving your tractor around it all the time and getting annoyed when they won't refuel you, or any number of things. And I guess, like, Ilia, what I'd love help understanding is, like, why is this space so different than those t-shirt companies, than those DocuSign competitors, than those other kind of businesses where they can easily get to a point where they just kind of work and are unblocked, whereas in robotics it's always a, like, fighting the next problem to keep the thing moving.
Yeah, the first comparison that comes to mind is, imagine yourself running a restaurant.
Yeah.
Which, like, even if you've never run a robotics company, you can kind of imagine what that would involve. Hiring people, ordering supplies, putting together a menu, and that kind of thing, right? Imagine if every new project you took on, you weren't actually sure if the beef you're getting from your manufacturer is actually beef. And if it is beef, is it the right cut? And will it work? Like, fundamentally, will this new dish you're putting together, will it even taste good at the end of the day? And I think there's a very kind of similar case here where when you're working on a robot, the system is so interdependent, where every step of the process, from sensors to hardware to electrical to software to deployment to support to, repairs and RMA and customer service, are so tightly coupled that a breakage in any one of them breaks everything else.
Yep. And ruins your big demo to the investor, the press member, or the whatever.
Right. And people won't really accept an answer of, well, the firmware got updated and now it's no longer putting out the message type we expected, and now we're stuck.
Can't you just go back to the old firmware?
Yeah, sometimes. sometimes not.
What's interesting about this is, like, as innovative, forward-leaning, blah, 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 whichever BS term you want to throw at it, robotics often looks like. Oftentimes people in robotics can be kind of rather conservative about the technologies they're willing to try, because, like, what's the point of trying this if it screws up everything else in my product?
Yeah. And we talked about this many episodes ago where we were talking about, like, hey, how could I automate this little Nerf gun robot? Mm-hmm. Like, how can we make this a general thing? And it's like, well, this robot has been so optimized for economies of scale that the little motor driver is probably, 5 cents worth of components that have been very carefully selected to just barely work for just this one application. And in robotics, you're kind of limited by space and cost and power and complexity, where we would love if there was buy a motor driver and it'll work on everything from tiny little cheap motors all the way up to giant industrial ones, and also cost $20 and also only be the size of a matchbox.
Yep.
Like, that'd be fantastic if that existed.
Yep.
But it doesn't. And this is true of all kind of engineering fields. Another much more mature market you could think of is aerospace. Mm-hmm. And it's the same thing of, why does it take a decade or two to release a new airframe? It's because every component is dependent on everything else.
My friends at Boom actually just had their first flight, and they were founded 10 years ago.
Yeah.
Their first flight of their demonstrator aircraft, not even the one that they actually want to sell.
So, quick comment. I love what they're doing.
Yeah.
I think their demonstrator is using engines that they did not build.
Yeah, but no one builds their own engines.
But their goal is to build their own engines. So the demonstrator,
that goal has changed from time to time, and I can't remember what the latest is. I know there was a point in time where they did not want to build their own engine.
I think now they have no choice because nobody's willing to sell them an engine. Anyway, we're not experts on this topic, but great example of that, right? Great demonstrator thing, but it's not using their engines. If they are in fact planning to build their own engines, the demonstrator has demonstrated that they can build
an airframe,
a somewhat comparable airframe that somehow has some integrated avionics.
Yeah, that can fly at similar speeds.
Right. Great. It's like step zero in a lot of ways of building an actual aircraft.
Yeah, it's step zero compared to launching a t-shirt company.
Yeah, exactly.
Yes.
Right.
It's step like 54 for starting a new airplane OEM.
Yeah. And again, like, I think they're doing something very
But
brave,
it's comparable to, like, robotics is not the only default blocked industry.
Yeah.
Basically any regulated space might be. Pharmaceuticals is often kind of default blocked unless you have enough money that you have 6 years of runway at a time, and they can just kind of spend your way through being blocked.
Yeah. Yeah. I think not blocked businesses are either in spaces that are extremely well understood, t-shirts or restaurants or whatever, where there's still opportunity to be innovative, but you're not innovative on the fundamental components of what you're doing.
Yeah. You're not being innovative on the platform.
Right. Or they're more modern software-based businesses where, again, everybody's reselling AWS for something.
Yeah.
So if I'm the 30th company to resell AWS resources for some specific thing, I don't have to be surprised that AWS is suddenly going to morph tomorrow into something completely different.
What's interesting about your restaurant analogy, I'm not a restaurant economist by any means, but many restaurant ideas, I think, had been blocked previously by the high cost of entry of setting up restaurant one.
Right.
Where like the first restaurant might literally require $1 million to rent the space, buy the furniture, hire the staff, buy the food. And then you're hoping that the margins on that can pay back that $1 million in the first couple of years. Now that food trucks are a thing and are a generally accepted thing, that entry cost is now in the tens of thousands of dollars. And I think kind of similarly, that's because a food truck is a far more easy to use platform than finding a restaurant space, doing a full build out, doing a whole blah, 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 getting people to come to the location for the first time. And you'd probably see in spaces that are currently default blocked or have more blockers, you'd probably see more innovation more quickly as they move to more reusable platforms, as they move to easier to understand platforms. Because there's plenty of chains local to the Bay Area that start off as a food truck, became 4 food trucks, and now are a chain of restaurants.
Right. Yeah, exactly. And I think robotics is starting to have that.
Yeah.
We're part of that.
That's what we're hoping to do.
Yeah, we're part of that effort is to kind of make robotics easier to instantiate in a way that there's a bunch of stuff built for you already.
Yep.
But robotics will always be a little bit harder than general purpose software because it's tied to physical reality.
Oh, yeah.
Because inertia still exists, because battery life still exists.
There's no software update we're pushing to solve inertia?
Yeah, maybe in a few years.
That's a whole other business.
Yeah.
And I would say a rather valuable one.
Solving inertia. Watch the movie Primer if you want to learn more about that.
I haven't seen that. Why? What are other reasons that can make robotics be blocked besides just, there's a physical component? Because there's hardware, but t-shirts are physical. There's other hardware. I think it's easier to launch a consumer electronic device that can get commercially successful than it is to launch a commercially successful robot.
I think I'll put a little bit of a caveat there because I think it's also complexity dependent. Mm-hmm. Launching a new cell phone is very difficult. Launching a new Bluetooth speaker when you're just glomming together Bluetooth receiver from company A and speaker from company B is a lot more easy. But I think complexity does play a factor, and I think robotics in general tends to be more complex.
Yeah.
There's moving parts, there's more control, there's more intelligence.
Yep.
And so your barrier to entry is already much higher because of the complexity of the problem.
Yeah, I mean, I think of when people talk about starting software companies, it's or investing in software companies, it's what is the one thing that they're building? And for almost every robotics company, there's 60 or 80 or 100 things that you're building.
Yeah.
And you have basically no more money than those software companies do.
Yeah. Yeah. And usually you're spending a lot more in CapEx.
Yep.
It's rare to find a person who can do mechanical and electrical and software and usability.
And those are kind of the only people who are worthwhile for a vertical robotics company with sub 10 people.
Right.
You basically can only afford to hire people who can do everything.
Which are obviously come at a premium and are very difficult to find. Yeah. I mean, I think robotics is starting to, I think our technology is developing to the point where compute is getting cheap enough, and we've talked about this before, and kind of becoming plug and play enough that you can start to go in this direction where you can compare robotics to kind of a more complex consumer device.
Yeah.
Equivalent maybe to launching a consumer, tablet, for example.
Yeah.
Where you don't quite have the regulatory pressure and your UI doesn't have to be quite as pretty. But
to that argument, how many startups have launched a consumer tablet from a standstill?
Yeah.
That have then become valuable.
Yeah, exactly. I mean, you can, not in the tablet space, but in the phone space, you can count them on one hand, right?
And most
companies.
of those are startups that like raised a whole bunch of money out of the gate. And yet, like we've talked before about how groups like that often are unable to ever do anything in robotics.
And that's the other thing is that obviously materials are expensive.
Yeah.
Very, very difficult to scale production from hand-built ones and twos to where you need to be of hundreds or thousands. There's companies that specialize in doing that kind of work, but that's still very, very expensive. And it's a big bet. Every design revision you're doing, coming back to the complexity and the interconnectedness, if you realize on robot number 50 that you've messed up some component in your system, that's a big cost.
I mean, there's a robotics company that I know of that has many robots deployed to customers and then started realizing they didn't do like design validation. And they have many more vehicles out there than they can easily do anything with that fundamentally are designed to not work. And that's a level of risk that not many other spaces have.
Yeah. I mean, compared to that, I can only really think of the automotive industry.
Yeah.
Every new startup in automotive EV space right now is funded to the tunes of tens of billions of dollars to get anywhere.
A friend, Ed Niedermeyer from the Autonocast, once offhandedly, jokingly told me the only way you can start an EV company is with a whole lot of fraud. And just like tell investors anything that gets them to give you all of the dollars so that you have a decade of lying to them all before you have to actually have a real business.
I mean...
He's a noted Tesla critic, I should add.
I wasn't even thinking of Tesla. I was thinking of the other like dozen EV companies that have either been criminally prosecuted or are about to be criminally prosecuted.
So it sounds like what we really should do, maybe not after...
Get into fraud?
Maybe not in the next year or two. But maybe we have some friends who have a big test site. And I can't remember... I don't know if we're allowed to say that we're officially friends with them or not. So I won't, but maybe they'll respond after and say that we can. Big test site that they want to like host other robots at. Maybe at a certain point, we get a whole bunch of different vehicles that are already retrofit, that have polymath autonomy on them. And we let potential customers just build application layer against specific real physical vehicles for multiple years until they have to actually get things going. Nicole on the sidelines is getting really jazzed. I mean, the only problem is of the vehicles that we're on, half of them are things that we never would have even thought to have bought and put hundreds of thousands of dollars into to have in the test site. What do you think, Ilia? Should that be our next thing?
There
a robot farm of
There's a few groups who've tried to do that, especially for focused efforts like disaster recovery. There's testing sites where you can put your robots through the paces of like a gravel pit.
I mean, like 15 polymath robots. Customers can just play against the API.
I understand. Yeah, I understand. And and there's groups that have tried to do that. The catch ends up being that the market isn't quite ready for that yet.
Yeah.
Because what you're basically describing is robotics currently is in the 80s equivalently of computer tech. We're going to skip the PC era and we're going to go straight to AWS. And like, maybe that's a bet to make. But I think for AWS to be feasible, you have to have the entire internet of
given
demand.
Given how annoyed you are at the fact that our test tractor keeps on turning its whatever into a solid block of carbon, then maybe we need to buy a new test vehicle anyway.
Yeah,
we can slowly, incrementally build ourselves a fleet of test vehicles.
I am all for it.
Yeah.
I'm just cautioning that as a business model, robots for software test rent is something that's been tried and the demand is extremely low.
What would be the first vehicle that we'd put in it?
Something harmless, hopefully.
Tank?
Yeah, tank. One of those $10 million bulldozers that can just drive right through a building.
Well, on that note, are we actually going to do a podcast next week, Ilia? Or are we gonna make this 3 in a row?
Yeah, we could. Let's shoot for 3 for 3.
It's going to be world changing. Dear listener, if there's not another podcast released next week, I will publish Ilia's home address. Feel free to do with that what you will.
I think send a complaint to our knowledge AI system at kai@polymathrobotics.com.
I like that we haze the interns more than anyone.
Alrighty.
Yeah. Well, on that note, what do you want to talk about next week?
We'll find out.
Well, thanks so much for joining us. We'll talk to you soon.
See you next time.